Hello, everyone. Thank you for joining us for our AWS webinar series, where today we are diving into a very topical discussion around the concept of moving from data monolith to data mesh. After today's session, we hope you will be able to walk away with a full scope of what tools you might need to decentralize, federate, and govern your data, what considerations should be taken when architecting for this concept, and whether data mesh is really right for your organization. Finally, we will also showcase how some AWS customers today are approaching data mesh as part of their next generation data management strategy with partner solutions found in AWS Marketplace. I'd like to take a moment to introduce our two expert panelists today. First, you will hear from Helen Beal. Helen is a DevOps and Ways of Working coach, Chief Ambassador at DevOps Institute, and an ambassador for the Continuous Delivery Foundation. She is chair of the Value Stream Management Consortium and an analyst at Accelerated Strategies Group. She hosts the Day-to-Day DevOps webinar series for BrightTalk. You'll find her regularly speaking on DevOps topics and is an editor, a DevOps editor for InfoQ. She regularly appears in TechBeacon's DevOps Top 100 list and was recognized as the Top DevOps Evangelist 2020 in the DevOps Dozen Awards. Our second speaker is Sandipan Bhaumik, an analyst specialist solutions architect with AWS. Over the past 15 years, Sandy has worked with organizations in different industrial sectors like financial services, insurance, healthcare, FMCGs, and retail, helping them build solutions that drive insights from their data. Here at Amazon Web Services, he works with customers to solve their complex analytics challenges and helps them transition from traditional methods of working with data to a more modern, unified approach in the AWS cloud. While we will not facilitate any live Q&A today, you're welcome to submit any questions through that QA window, and our speakers will review your comments and respond if appropriate after the webinar. We will also be running a brief survey to gather your feedback at the end of the webinar, so we'd love for you to hang on for just a moment and complete that as well. We've got a lot to cover today, so without any further delay, I'll pass the floor to our first speaker, Helen.
Thanks so much. As you said, I'm Helen, and today we're talking about how to architect for data mesh and unlock data availability at scale. So moving from monolith to mesh, as you said. So we're going to start by talking about what data mesh is and then talk about how the journey works, how people adopt it. There are 4 principles we're going to cover, and we're going to dive into governance as well in particular today. So let's talk about the origins of data mesh. Well, as we know, data has this nature where it is very ubiquitous, it's distributed, and it's ever present. We've been talking about big data for a really long time, but it's only getting bigger, and most organizations are continuing to generate more and more data, and there are no signs of that slowing down. It's happening because we all want to augment and improve every aspect of business on our lives with the data. We want to be data-driven, perhaps even insights-driven. But we haven't done that well recently in terms of addressing the scale of the volume of that data and the data processing power that is needed to make that data available. And we haven't done that well in tackling scale in some other dimensions, in particular around changes in the data landscape, the proliferation of the different sources of data as well. So it's coming from many, many different places. And this diversity of the data use cases that we have and the different types of users that want to access that data, the more we realise how we can leverage it to improve our business models. And we also haven't been that great in our agility around data, so in terms of our speed of response to change. So this lady here is Samakta Ghani, and she's the Director of Technology at ThoughtWorks, and she proposed an evolved architecture, which is the data mesh, initially in some articles on Martin Fowler's website back in 2019 and then in 2020. The first of those articles was called How to Move Beyond a Data Lake to a Data Mesh. And she opens that article by saying this, that data platforms based on the data lake architecture have common failure modes, and they lead to unfulfilled promises at scale. So to address the failure modes, we need to shift from the centralized paradigm of a lake or its predecessor, the data warehouse. And we need to shift to a paradigm that draws from modern distributed architecture, considering domains as the first class concern, applying platform thinking to create self-serve data infrastructure, and treating data as product. And she went on to publish a book earlier this year in 2022, published by O'Reilly on this topic, data mesh, delivering data-driven value at scale. So that's the origin. So let's think about that in the context of the things that have come before and some of the things that are also coming through at the moment. So you've probably heard of a number of different data architecture patterns. We've already mentioned warehouses and lakes, but you may also have come across fabrics. So let's look at those three, the mesh, the lake and the fabric, and how they compare. So a data lake is a storage repository. It holds a vast amount of raw data in its native format. So hierarchical data warehouse stores data in files, folders, and the data lake uses a flat architecture to store the data. So here, the advantage of data lake, it's centralized, singular, it's schemaless data store with raw as is data, as well as some massage data as well. And it's the mechanism for fast ingestion of data with the appropriate latency, and it helps to map data across various sources, and it gives visibility and security to users. You get a catalogue to find and retrieve data and a costing model of centralized service with the ability to manage those governance angles, so your security and permissions and data masking. Now, a data mesh does aim to solve many of the problems of a data fabric, namely the difficulty of managing data in this heterogeneous data environment, but it does tackle the problem in a fundamentally different manner. So our data lake, that centralized thing, our data fabric seeks to have a single virtual management layer atop the distributed data. So we've now got the big difference, lake centralized, fabric and mesh both distributed. But fabric has this single virtual management layer atop the distributed data, whereas the data mesh encourages distributed groups of teams to manage the data as they see fit, with some common governance provisions that we'll look at in more detail. So essentially, data mesh flips data fabric's sort of product and tech-centric approach on its head, and it centers around people and expertise, and it emphasizes delivering high quality data, but into the right hands. It's also worth noting that they're not mutually exclusive. You can combine data mesh and data fabric. They're kind of complementary, and if you combine them, some people refer to this as meshy fabric. And when you use this, you can overcome those bottlenecks that you might be seeing, but ensuring that data remains at the forefront. So data leaders determine when and where and how to implement each framework in their organization. So you've got quite a number of options here. So let's have a closer look at when data meshes make sense. So you may want various things. You want to be data driven. You're really focused on customer experience and particularly things like hyper personalization. You want to also reduce operational costs through the data driven things you're doing, and really empower your employees to do things around trend analysis and business intelligence so that they can really make very strong guided business decisions. But you might be experiencing some problems that are keeping you from achieving those goals. So it may take very long to onboard data. You may have bottlenecks in your analytics workflows. Your centralized teams may be really bogged down, maybe even burned out. You'll have maybe some quality issues, or you're not able to find the data that people want or the answers that people want. You might be suffering from a lot of technical debt. You may have resource constraints or skilling challenges around having very, very hyper specialized data engineers, and you may be really feeling the pain from all of these proliferating data sources. And it might be hurting you. You might have recognized that actually having a centralized team, a silo effectively around big data, is actually making it hard for people to do work. So, most data users at large organizations aren't really familiar with data lakes, and we've got these vast troves of data, but with time, there's kind of a rampant collection of data and lack of organization. It's quite common for a data lake to become a data swamp. And historically, the people that have been charged with maintaining the data lake were not as the best equipped people perhaps to manage them intelligently, because they weren't close to the business requirements and the customer. So data lake managers didn't only need to just comprehend the needs of consumers, they also needed to grasp the domain expertise of the data producers. So without this kind of mesh framework, our distributed framework, the average data lake manager fails on getting these domain expertise and the intelligent data management correctly. But under the data mesh framework, those closest to the data are responsible for the health of the data, so your quality of that data, delivering data as a product. So that's partly about the agility. We'll go into that in more detail. and also communicating objective measures such as the quality against the success and the value that the data is creating. So I mentioned the 4 principles, and these are they. So the first one is about having a domain-oriented, decentralized data ownership and architecture model. So that means we understand what the business domains are, and the data is federated across those domains. We don't have this one centralized lake. We are accessing the data from the places where the people that want to use it are coming from. So we have data as a product, and this means we are looking at it as a long-lived thing that we are continually enhancing. So we see it as something that's standalone, that belongs to that domain. Then we have the self-serve data as an infrastructure, as platforms. This is our platform thinking piece. This is where we are saying that we know that we need to serve this at high quality, and it needs to be fast, and it needs to be really available to the people that need to access it. So they need to be able to choose what to get, and they need to not have any availability or performance problems with the platform that is providing it. And finally, this quite big one, governance, that we're going to look at a bit later, but we're going to look at all of these in a bit more detail. So traditionally, with our data lakes, we've had the centralized data team. It's a siloed data architecture. We've been using this across most organizations, and we've separated the producers from the consumers, and we've stuck the central data team in the middle, and they're receiving and processing the data and making it available. It's quite a lot of weight on them, and they become the conduits, as you can see here, for both the data and also the requirements for the data itself and any enhancements around the data itself, or also the way that the data is provided, so the platform behind it. And there are some problems with silos, and they're problems that we have recognized very much in DevOps. We talk about silos an awful lot in DevOps, and this is because one of the things we're really focused on is improving that flow, so making things go as fast as they can. And one of the biggest things that slows down flow is silos, because between silos we have handoffs, and whenever we have a handoff between teams, we create opportunities for host-related problems, so things like delays and waste and bottlenecks and errors. So we're creating opportunities for things to go wrong. So what do we do? Well, as we've learned, conceptually, data mesh is founded on decentralization. So we take away that central team, we take away the silos, and we break down any barriers to improve flow. So we distribute responsibility to the people that are closest to the data, and this helps us support continuous change, which is part of the product piece that we'll come to as well, and scalability. So the question really is, how do we decompose and decentralize the components of the data system and their ownership? So here you can see some example domains, a source-oriented data domain and a consumer-oriented data domain. And then we've got the data consuming application. But at the bottom of all of this, we've got a domain agnostic data infrastructure platform. So this is our mesh that's allowing these domains to exist and supports making that data available, the provision and discovery of data, and the way that people need to consume it and make value out of it and provide feedback for ongoing improvements. So now we've got domains. Now we need to have products associated with domains. So treating data as a product means it's long-lived and it's owned by a cross-functional team who know it intimately. They understand the business requirements, they understand the customer, and therefore they understand the data. And these data product teams include the roles that we would see on any product-oriented team, so things like product owner and product developer, as well as the engineers and the testers. And the product is long-lived, which means it's continually and incrementally involved and enhanced with its customer needs. And this is fundamentally an agile concept, so the agile principles around experimentation apply. So underpinning agile, we have this idea of empiricism, and empiricism says that we experiment and we constantly measure, and we go in cycles, continuous improvement cycles. So we experiment with something, we implement it, we deploy, we receive feedback, and we keep going around this product life cycle loop, making sure that our product is continually enhanced and improved to deliver what it needs to for our customers. So the third principle was around self-service. So the self-service architecture really is built around planes. So the platform capabilities can fall into multiple categories, or we call them planes in this model. So a plane is representative of a level of existence, so it's integrated yet separate. So similar to physical and consciousness planes or control and data planes in networking. A plane is neither a layer, and it doesn't either imply a strong hierarchical access model. So a self-serve platform can have multiple planes that each serve a different profile of users. So here in this table, we've got an example of 3 different data platform planes. We've got the data mesh supervision plane, and there are a set of capabilities here that are best provided at the mesh level. So there's like a graph of connected data products globally. And while the implementation of each of these interfaces might rely on individual data product capabilities, it's more convenient to provide these capabilities at the level of the mesh. So for example, the ability to discover data products for a particular use case is best provided by search or browsing the mesh of data products, or correlating multiple data products to create a higher order insight is best provided through execution of data semantic query that can operate across multiple data products on the mesh. So the supervision plane is looking across the different domains, across the different products. Then we've got our data product developer experience plane, and this is the main interface that a typical data product developer uses. So this interface abstracts many of the complexities of what it entails to support the workflow of a data product developer. It provides a higher level of abstraction than the provisioning plane, and it uses simple declarative interfaces to manage the life cycle of data product. It automatically implements the cross-cutting concerns that are defined as a set of standards and global conventions applied to all data products and their interfaces. And that's giving us a little clue or insight into some of the governance. So while we are federating or distributing authority to the domains and the products, we do have some sets of conventions and standards that go across all the products. Then we have our data infrastructure provisioning plane, and this is supporting the provisioning of the underlying infrastructure. That's what we need to run the components of the data product and the mesh itself of products. So this includes provisioning of things like distributed file storage, storage accounts, access control management systems, the orchestration that allows us to run data products internal code, the provisioning of distributed query engines on graphs of data products, and either data platform planes or only advanced data product developers use this interface directly. So it's fairly a low-level data infrastructure lifecycle management plane. So whilst there is some common patterns across domains, it's also important to note that the distribution allows the different domains to have some autonomy, so they can make some of their own architectural choices, because they'll have different types of data. Remember what we said earlier about the variety of different data use cases and users. So different sorts of data as well all means that different architectural choices will make different make sense for different teams. So let's talk about governance, because I think certainly in the DevOps world, we've talked about decentralization quite a lot. We talk about distributing authority, we talk about breaking down hierarchies and breaking command and control and dominator hierarchies and distributing authority and decentralizing. And we talk about that on many different levels. We talk about it around things like release management and change, and trying to get away from these bottlenecks that happen in the flow of work. And this is a similar conversation that we're talking about now, decentralizing governance. And this can sound quite dangerous to organizations that have been used to using that centralized model as a way of controlling checks and balances. But it's not as black and white as just decentralizing everything. The overall shift in data mesh is from a one-size-doesn't-fit-all centralized architecture to a choose-your-own-adventure decentralized architecture that is optimized for the domain. But there are aspects of data governance that will necessarily need to remain with a central group in order to strike the balance and ensure that all of the aspects of governance are adequately provided for. So On the left, we have examples of things that are owned by the domains, the things like the quality, where the data is coming from, the security and authentication around it, some classification and compliance, and the way that between the domains we standardize the entities. Whereas in the central IT, we've got some global risk and compliance standards. We're also seeing data security at that level. We need data security at lots of different levels. And there we're seeing lineage reporting, but also the inter-domain entity standardization, so between the domains. So rather than dictating a command and control centralized governance function without any consideration for the nuances of each domain, our data mesh model federates some of the governance policies and practices while leaving some central to ensure consistency and that cross-domain collaboration, because it's very rare that we have a truly autonomous organization. We have this need for our domains to collaborate. There are often dependencies for systems and there are often dependencies within teams. And we learned about this in, well, I was going to say in DevOps, but we learned about this in our industry, but we use this concept a lot in DevOps. So back in 1967, Melvin Conway, then a computer programmer, suggested that organizations design software systems that mirror their communication structure. And this happens very naturally because when we're designing components for a system, teams need to work with each other. So each team designs their own component. So then we have to connect the components. So when we have very large teams that are siloed, what we end up with is a very large monolithic system. So that means it's tightly coupled. There are a lot of dependencies in it. In that 2019 article on Martin Fowler's site, Samantha Gunn calls data lakes out as being monolithic and data mesh as being a distributed architecture. So in Agile and DevOps, we've known for a long time that smaller, autonomous and cross-functional teams help us optimize flow. So we've promoted them heavily. This is the product model that we did look at earlier. And just to reiterate, the aim of this way of working is to optimize the flow of work and therefore increase the value of that work by reducing the number of handoffs. Again, we looked at this with domain ownership. We saw that having that centralized team was creating lots of handoffs and bottlenecks and slowing things down, slowing the value to the customer. But when we have small, loosely coupled teams, we have loosely coupled distributed systems. So we've already seen huge adoption of technical architectural models that move away from monoliths, so things like microservices. And data mesh is really these principles applied to data at scale. Of course, we have things like service mesh that we've seen around in the microservices part of the world as well, which is already using these type of principles. So the key takeaways around data mesh, it is a new thing. It's trying to deal with data at the scale it is now. So it's got even bigger and we've got even more issues around proliferation. So we're dealing with data at scale. It follows the principles that we've been learning around distributed ways of working, which are there to optimize flow. And we have distributed architectural patterns that support these distributed ways of working. They go completely hand in hand. But you need to work out if it's for you, whether it's something that is going to work in your environment, what it would take for you to move from one method, so whether you're with data warehouse, data lakes, to something else, perhaps even whether you want to use data fabric instead, or perhaps you want to create that meshy fabric. So with that, I shall pass over to Sandy, and thank you very much for your time.
Thank you, Helen. Hello, everyone. Thank you for taking out the time to listen to this webinar. My name is Sandeepan Bhaumik, and I work as a specialist solutions architect for analytics at AWS. I work with businesses from different industries, helping them solve the problem of data access and availability, ensuring they can realize the value from their data at scale. I have a lot of conversations with customers, and in these conversations, the topic of data mesh have been coming up a lot lately. So, in this session, I want to get you thinking on how you can unlock value from your data and make it available to the right users at the right time in a secure way. After this session, you will have some idea on whether a data mesh strategy is right fit for your organization, how it works on the AWS cloud, what are the alternative architecture patterns, how you can use both AWS native and partner solutions to build, govern, secure, and share data products across domains. Companies are really struggling with getting value from their data and evolving to a data-driven organization. A recent Forbes article suggested that 99% of businesses want to become data-driven, but only 24% have been successful. Why is that? Well, there are certain barriers to drive business outcomes with data. Companies tend to focus on collecting and storing their data rather than focusing on how they are going to use it. They struggle in supporting a collaborative model of data producers and consumers where different parties seamlessly exchange data assets. It is not only a technical challenge, but it needs a shift in mindset. Integrating data governance and compliance across the organization is a challenging task in itself, and enabling common access across the enterprise while ensuring trust and confidence in the data makes it way more difficult. When I talk to customers, I hear them expressing some common themes of challenges they face. It is interesting, isn't it? Businesses from different industries with different goals, different business models, they all face the same common problems when they want to realize value from the data. Do any of these resonate with you? Look, companies don't lack data. They struggle with transparency of information assets across the company and tying data to a specific value or business outcome. Customers who are successful as data-driven organizations treat data as a product. They collaborate and share data across the enterprise to drive business impact. They provide a federated data governance and compliance model between data producers and data consumers. Not all governance strategies can be based on a one-size-fits-all model in complex businesses. You have heard Helen talk about the story behind the data mesh, how it originated, and the principles it is based on. She also mentioned that you need to assess whether a data mesh strategy would suit your organization. And it is very, very important to note data mesh isn't the solution for every company. It is an appropriate strategy for businesses with complex application landscape driven by business units separated by regulatory, legal, geographical, or product-oriented considerations. Let me help you assess this quickly, and this is at a very broad level. Think of the following points I'm going to mention and see if your organization resonates with one or more of them. Is your organization a mature, decentralized business with significant investment in data that is organized in silos? Has your business grown through heavy acquisition where different parties demand local autonomy? Do your employees want to unlock innovation across these diverse business units in your organization? Does your organization need decentralized governance but also need enterprise-wide transparency? Are you answering yes to these questions? Then you might think of a data mesh strategy. Let me give you an example to make it a bit more simpler. Think of an insurance company. This insurance company has built its business by acquiring smaller businesses around health insurance, home insurance, and motor insurance. Now, the company wants to cross-sell to its customers. And in this situation, it is common to see completely disconnected data lakes or environments for each of these areas of the business. This makes it increasingly difficult to create a strategy where they can use data from across the whole enterprise for a cross-sell use case. Now, in the next few slides, we will revisit the core principles of a data mesh, and I will show you how different AWS native services and partner solutions can work together to meet those. A core principle of data mesh is to treat data as a product. What is a data product? Well, a data product is simply a broad, cohesive collection of related data analytics, and machine learning capabilities that are aligned to a specific use case or goal. For example, this might be a customer 360 capability, which could incorporate data from across multiple lines of businesses to create a clear picture of a customer across the enterprise. This data product is intended to enable or drive a defined, well understood, quantified business outcome. Think of the example of the insurance company I cited earlier. They might want to build a customer 360 data product with customers across the different business units like home, health, and motor insurance. This will help them sense and respond to signals throughout the customer lifecycle or create a real-time, persistent, and precise view of the customer journey. Next, core to the data mesh is the idea of specific data domains. For simplicity's sake, think of a data domain as a collection of related data. This data could be structured data, such as transactional data. It could be unstructured data, like voice or video data. It could be real-time streaming data, like what you might get from weblogs. We need to build a foundation for this data domain, which needs to support these diverse data structures, enforce security and compliance requirements across different business use cases, and be able to scale in a cost-effective way. Keep in mind, in most cases, each of these specific domains can have unique governance and security requirements as well. The modern data architecture is an architectural design that can provide this foundation. It grows with the business and creates a connective tissue around the data that you need from across a particular domain or business unit. With the modern data architecture on AWS, customers can store domain-specific data in a data lake and use a ring of purpose-built services around the lake, allowing them to make decisions with speed and agility. These purpose-built services are not restricted to AWS native services, but can easily work with third-party and partner solutions. The benefit of using this pattern is that you can get started quickly and can enable only specific technology you need to solve a particular business problem. So, if you want to develop and run machine learning models on top of your data, just use the machine learning services. If you want to store your data in a structured database and build a data warehouse, just use the data warehousing services. This allows you to drive business value quicker and steer to alternate direction in times of adversity. When the business changes, you can evolve the architecture incrementally. Now, later in the presentation, we are going to talk about some customer stories where you will see how some businesses leverage the modern data architecture with AWS and our partner services. Data mesh is a pattern to organize and deliver data products belonging to different data domains in a consumable way. These data products can be discoverable. Consumers can request access to the data products and gain access to them. A producer domain responsible for creating and maintaining the data product can use purpose-built services following the modern data architecture pattern that we just discussed and create a data product and share it on a centralized catalog. Consumers can browse the centralized catalog, discover data products, and request for access when they need to use the data product. This happens without any copying of the data, thus preventing from creation of data silos. The security is managed centrally on this catalog. This enables self-service consumption, another core principle of the data mesh. Let me explain this with the insurance company example. Let's say the marketing department of the insurance company wants to build a customer 360 data product. In order to do that, they will need the customer data from the different lines of businesses like the home insurance, the motor insurance, and health insurance. Now, each of these domains can register their customer data product in the centralized catalog and then the marketing domain can go and consume the data product and build the customer 360-degree product. Once that is done, they can register the customer 360-degree product in the centralized catalog, and then other domains can use that product if they needed to. Let's look at a bigger picture now. At a high level, you can think of a data mesh as a collection of domain-specific modern data platforms that unlock enterprise data products, provide federated governance, and empower self-service data sharing. Remember, a data mesh is not a centralized data store, but an enterprise view across all the distributed data within a complex organization. Now, if you think a data mesh is not fit for your organization, you can use the modern data architecture approach, centrally store all the data in your data lake, use purpose-built services for different use cases while managing the security and governing the data on top of your data lake storage layer. I have mentioned federated data governance in the previous slide. I think it is best to talk about it at this point. And of course, this is another core principle of the data mesh. It is the idea of implementing federated access control to data owners. So imagine there is a place for different data owners to register their data products and then apply some common security services on their data products through a single identity provider with authentication tokens vended across producers and consumers. So rather than managing security at both ends, the producer end and the consumer end, it is just managed in this space centrally. Registering data products on this common catalog means you can build a consolidated metadata of your data products and enable searching to facilitate data discovery. It also facilitates central auditing, so auditors and organizational data stewards can review the events and audit on one common place. Let's have a look at how data products are built and managed on AWS. Producers can ingest data into their Amazon Simple Storage Service bucket, S3 buckets, using a set of ingestion mechanisms that can be managed by the producers. In fact, producers are responsible for the full life cycle of the data. This producer can create the data products using different services, whether it's AWS services or third-party services in the producer domain. And then these domains can register the data products and the associated metadata to develop, automate, and manage the data products in lake formation. They can then control consumer access through federated governance and policy enforcement at this layer. So how can these data products be shared within a domain? When data consumers request access to the data product, producers grant access to their catalog via resource sharing technique. Data owners grant lake formation permissions to a consumer account through federated data governance permission and policy management. Now, zooming out a bit, let's look at how these data products can be shared across different accounts. Let's consider 3 producer domains. And here these are 3 different lines of businesses in 3 different AWS accounts. They host their own data lake. They are responsible for the data products that they develop and they manage. Now there are 3 consumers who want access to different data sets from these different business units for different purposes. For example, consumer X wants to run ad hoc queries, run machine learning models, and even store the data in their data warehouse. And they just need access to table A from line of business 1. Consumer Y wants to visualize data on table A and table B, which come from line of business 1 and line of business 2 respectively. And consumer Z wants access to all of the tables that come from the 3 different line of businesses. Now, when these producer domains register their data products on lake formation, it forms a data catalog and applies policy control and data permissions. And as you can see from the permissions that were applied, line of business 1, owner of table A, has granted select permission to consumer X, Y, and Z because all of these consumers need access to that table. Similarly, line of business 2 have granted select permission to consumer Y and Z because Those are the consumers that need access to table B. And line of business 3 has granted select permission to consumer Z because that's the only consumer that needs access to table C. Now, the security can be granted at more granular level than just a table. It can be granted at column level, row level, or even at the cell level. It is worth mentioning that data products in the modern world are seldom built solely on first-party data. Using third-party data is a very common practice in building these data products. For instance, take our example of building a customer 360 product. If the insurance company wanted to create personalized promotions and offered customers discounts on different retail products, they would need to rely on various data points like points of interest, social demographics, retail locations, etc., which the organization might not be generating by themselves. In this case, they would need to procure the relevant data products from third-party providers and combine them with the customer 360 data product to apply the right promotion to the right customer. However, finding, buying, licensing, securing, and managing a third-party product can be major overhead for these businesses. AWS Data Exchange makes it easy to find third-party data in one data catalog. It makes it simple to subscribe to with consistent pricing options and integrates seamlessly with AWS data and analytics and machine learning services. It is the only data marketplace with more than 3,000 products and 250 providers. The data is delivered through files, APIs, or even Amazon Redshift query tables. They are delivered directly to the data lakes, applications, analytics, and machine learning models. As an AWS service, AWS Data Exchange is secure and compliant, integrated with AWS and third-party tools and services, and offers consolidated billing and subscription management. Now that we have seen how you can build data products on AWS and share them within other domains, let's have a look at two patterns on how you can distribute data while centrally managing security and governance at scale. In this pattern, data is distributed through one central catalog. Let me explain you the flow in this diagram. We have got three different accounts here. The producer account, the federated governance account, which is a central account that controls the catalog, and the consumer account. The producer account is responsible for creating data products, hosting the data lake, and managing the data through its life cycle. Think about the modern data architecture pattern in this domain. They have a central data lake where they use purpose-built services to either transform and enrich the data and store in different layers. And this could be done by AWS Glue, which is an AWS native service. It is a serverless ETL and data integration tool. But if they wanted to run Spark jobs, they could even use something like Amazon EMR or even a third-party solution like Databricks. Now, once the data is stored in the data lake, this location is registered in the lake formation service in the central governance account. And when this location is registered on lake formation runs Glue crawlers on these buckets. And what it does is it crawls the data objects stored in these buckets and automatically creates a data catalog in the form of tables, columns. Administrators can then grant access to different consumers on this catalog. Now, it is worth mentioning, you can see that the catalog is actually running crawlers from the central account, which means that any changes that happen in these data layers first gets propagated to the central account, thus giving an uniform control on all the data products produced by multiple producer domains. Now, this catalog is also shared with the producer account because the producer account might need to look into the catalog and all the changes that happened in this particular layer. When a consumer needs access to the data product, this catalog is also shared with the consumer domains. They can look into the data catalog, do some data discovery, and if they think that they needed access, they can request for access, which then a data lake administrator or a data steward from the producer account can grant access to. Once the consumers get access, they can use different services to query the data that is residing on the catalog. And all of this sharing happens without copying of data anywhere. When users come in through a service like Amazon Athena, which has got integration with Lake Formation vends a security credential to that user depending on what sort of access the user should have on the data. So if a user needs access to just certain columns in a particular database table, Lake Formation will vend that credential to that user so that that user can just access the intended data from that particular table. And this is totally managed by Lake Formation. Now, this is for AWS native services. I wanted to explicitly state the scenario with third-party solutions here. With third-party solutions, we haven't got any integration with Lake Formation as of today. What that means is that this vending of security credentials will not happen when you come in with requests from third-party services. In that case, the data will need to be offloaded to a local S3 bucket from where the third-party services can then access the data. Now, you have to be careful with this. If you're using it in that approach, you have to be sure that this copying of data into an S3 bucket doesn't actually create a data silo over time. So you have to apply appropriate practices to make sure that whatever changes happen at this layer is either reflected to the catalog in some way or does not affect the overall governance of data in your organization. Let's look at another pattern, and I will just scroll up again and down again just to show you the difference between these two architecture diagrams. You can see this arrow turns green and the crawler has shifted to the producer domain. So what happens in this pattern? Everything remains same in the producer account and producer domain. However, the crawler is now running from the Lake Formation service in the producer account. And that means that any changes that happens in this data lake in the producer domain first gets propagated to the Lake Formation catalog in this account. So changes get reflected here first rather than getting reflected in the central account. Now the producer domain has got flexibility to whether share the changes with the central catalog or not. Everything remains same with the consumer domain. A great AWS customer example that highlights using domain-specific data lakehouse organized in a data mesh is at JP Morgan Chase. JPMC modernized their data platform by thinking beyond just a monolithic data lake. They created a loosely coupled data architecture to allow for them to scale and innovate. They focused on data products across the enterprise and created federated governance and compliance mechanisms. This strategy drove overall cost savings, realized business value quickly, and promoted data reuse across the entire enterprise. Until a few years ago, FINRA ran its data warehousing infrastructure on premises. Organizational barriers and scalability limitations forced FINRA to create separate analytics silos, with each handling a subset of the entire dataset. And this resulted in data fragmentation. It made analytics very, very challenging. FINRA decided to completely rethink its data platform and started to build a scalable data lake on AWS. They built a central metadata repository and used purpose-built services for their analytical needs. For querying the data on top of the data lake, FINRA uses Starburst. Starburst Enterprise's proven integration with AWS made this possible. Today, FINRA uses Starburst Enterprise for ad hoc data profiling, business intelligence, and reporting. Teams of data analysts and scientists execute multiple concurrent SQL queries via JDBC and ODBC clients. This has resulted in faster insights at lower cost, improved scalability, elasticity, and accessibility, improved performance, flexibility, and cost efficiency. Zalando had siloed teams using different technologies that created operational complexity and hindered cross-stream collaboration and productivity. They spent massive amount of time on DevOps to solve these challenges with very little time to focus on their actual business. Zalando today uses Databricks that provides a unified analytics platform and simplifies infrastructure operations by using autoscaling and Spot instances. The support for multiple programming languages allowed data engineers, analysts, and data scientists to access and leverage the data to drive insights and build models at scale. SimilarWeb collects enormous amounts of web-related data to help marketers, brands, salespeople, and many others to analyze how their audiences interact with websites. They faced major challenges in managing the huge volume of data and building costly ETL processes. Today, SimilarWeb uses everything on AWS. Processing is mostly done over the data lake with Spark and Databricks, orchestrated by Apache Airflow. Then, queries are almost served to the UI through either DynamoDB or Hive before Firebolt was added to the mix. Firebolt helped SimilarWeb to simplify isolation of workloads for the new feature set and deliver queries that are consistently fast and predictable. They provided greatest cost performance and lowest total cost of ownership compared to the alternatives. These are great customer stories on leveraging the modern data architecture on AWS, using native AWS services and partner services available on the AWS Marketplace. Companies are building their data mesh strategy on top of AWS because AWS provides the capabilities to support end-to-end requirements, including creating domain-specific modern data platforms, connecting those platforms across the enterprise, and ensuring that we are using optimal tools that will drive the desired business outcome. This will result in a reduction in operational cost, increased agility that will unlock innovation, a reduction in technical debt, and a robust modern architecture that can scale to meet the needs of the future business opportunities. Data and analytics have become a competitive differentiator for enterprises. Customers choose AWS to enable domains to innovate and build data products. Our partner solutions play a crucial part as data stores, business intelligence and visualization tools, data integration tools, governance and security services in the modern data architecture framework. The products we discussed today and more are available on AWS Marketplace, and AWS Marketplace is a curated digital catalog that makes it easy to find, test, buy, and deploy the third-party software you want with the simplified procurement and controls you need. We have a broad and deep selection of data and analytics solutions offered by hundreds of independent software vendors, spanning advanced analytics, data integration pipelines, data governance, data sets, and more. AWS Marketplace can enable you to receive quicker time to value and thus return on investment with your third-party solutions. Recent third-party research found that it takes an average of 27 hours to find, buy, and deploy a solution through AWS Marketplace, compared with 52.4 hours through other procurement sources. That's an average time savings of 49%. This research also uncovered how AWS customers, such as yourselves, felt about their AWS Marketplace purchasing compared to other sources. As you can see on the right, a few of the highest rated benefits include cloud readiness of the solution, time to value, and return on investment. AWS Marketplace is supported by a team of solution architects like myself, data experts, product specialists, and other helpful humans to help you connect with the software and resources you need to prioritize your data and analytics initiative in AWS. So how can you get started? These solutions covered in this session, along with many others, are available to try today. If you wish to check our partner solutions like the Databricks Lakehouse platform or Starburst Enterprise, both offer free trials through AWS Marketplace. When you're ready to buy flexible pricing options such as free trial, pay as you go, and bring your own license, help you to unlock the best price and meet budgetary needs. There are also options such as private offers where you maintain a relationship with the seller or consultant. You can negotiate the price with them and generate a private offer for you via the AWS Marketplace. AWS Marketplace also supports standard pricing options such as hourly, monthly, and annually. If you migrate to AWS and want to take some of your existing tools, you can bring your own license as well. And the billing of these third-party products are consolidated on your AWS bill. There are multiple deployment options that help you to customize software provisioning to fit your security and governance policies, licensing terms, and more. AWS Marketplace helps you to customize and provision software the way you need it. Here are just a few that we would like to highlight today, including software as a service deployment method, AWS Data Exchange, CloudFormation templates, and containers. Finally, you can also complete the survey that will be sent out at the end of this webinar if you wish to learn more about the specific solutions that were mentioned today. We just covered quite a bit, and I hope you leave this webinar feeling confident about your next steps and approach to a data mesh or a modern data strategy. I would like to reiterate a few points before we close. The domain-oriented approach with self-serving capabilities of a data mesh enable organizations to be autonomous and increase pace of innovation. Think about the domain-oriented approach and the data product thinking. The modern data architecture approach can be used within each domain, and it offers a common tech stack. So if there is a new domain tomorrow, you do not need to train resources to adopt a new technology. If you are using a third-party solution or an AWS partner solution from the marketplace, you can still keep using them in the domain. Just keep in mind the federated governance would not work end-to-end with third-party solutions as of today, as I explained in one of the previous slides. AWS Lake Formation helps build data lakes quickly, provides cataloging, centralizes security management, and shares data catalog across domains. Last but not least, assess whether the data mesh is the right strategy for your organization. Think about the points I discussed earlier and do your own research. Thank you very much for listening to me in this webinar, and I will hand over to Erica right now.
Thank you, Helen, and thank you, Sandy, for those wonderful presentations. And thank you, everyone, for taking the time out of your day to join us. We really appreciate you being here, and we hope you found this information useful and getting your journey started with data mesh. We will be running a brief survey at the end of this webinar just to gather your feedback and input and help us improve our events in the future, and also learn more about what other use cases or topics you'd like to learn about. Thank you again, everyone, and we hope to see you on our next event.